So hello friends, in this video we are going to see about output register. In past videos we saw various other components of our 8-bit computer, and if you have not watched that video, there is a link in the description. Watch that videos so you could know what's going on in this video series. So let's get started. Output register. Basically, in past video I have not told many things about the output register. It will be output register which will be designed using a 16 by 2 LCD module, as well as for giving it for the value, displaying the value on the 16 by 2 LCD, we need various microcontrollers, and I'll be using an Arduino Nano here, which is a Atmega 328P microcontroller, as its programming is very easy and there is a inbuilt library for the serial data and clock I2C communication with this 16 by 2 LCD module, as we'll be attaching a I2C converter, logic level converter for this 16 by 2 LCD module. So we'll be getting the pins available for our data inputs, which will be converting the data from the bus from binary to decimal, and will be displaying that same data here. So how will be doing that? So first of all, here I have drawn the inputs for the from the bus. It is B0 to B7. As it is a 8-bit computer, we need 8-bit output. So B0 to B7 we have here input, which is here 74273. So what is this? It is a D-type flip-flop register. It is a 8-bit. So in past videos I have used 74173. If you while designing the register module, if you have not seen that video, you can click up the link. After watching this video, you can click up the link and watch the video. So this is the 8-bit, and 74173 was the 4-bit register, D-type register, and it is 74273 is 8-bit D-type register. So it is taking input in the 8-bit value from the bus, and it is outputting it is storing its side in it, and after getting a control signals, it is outputting its value to these Arduino Nano digital pins. And when these digital pins will be here, each and every bit will be declared as an input, and so when there will be the value in this register, it will be outputted onto these digital pins, and the value which is there in these digital pin will be converted from binary. It will be in binary format. It will be converted into a binary, and it will be then, as this value will be there in binary, it will be converted into decimal using the program, and then it will be displaying the value into the 16 by 2 LCD. So now we need to synchronize these Arduino Nano to display the 16 by 2 LCD with a control signal as well as the clock. So for that synchronization purpose, what I will be doing, I will be connecting one of the digital pin of an Arduino Nano as well as these 74273 with a clock of our 8-bit computer, and we will be running the code of conversion of binary to decimal, and the value outputting onto the displaying of these value onto the register by an interrupt. So how we'll be writing the program? So here is how we'll be writing the program. So this is how we'll be writing the program. So here we'll be declaring a constant character array, which we will be naming it as bus. We'll be defining the digital pins 3, 4, 5, 6, 7, 8, 9, 10 as an input, as it is 8-bit from 0 to 7. So these are the digital pins which we will be defining as input, will be defining the input pin as clock, int value is equal to 0 for the value which will be displaying on the board, the display. Then void setup int I is equal to 0 by looping from pin mode bus 1, from looping from I is equal to I is less than 8, I is equal to 0 to 8, and will be incrementing after each loop. Will be defining each pin as an input pin. Then after that we will be defining a clock pin as an input. Then we will be defining the clock pin as an interrupt pin. Attach interrupt digital pin to interrupt clock pin on signal. This will be function which will be run after the rising edge has occurred on the clock pin. So we will be going into the on signal pin. Here we will be doing a loop from I is equal to 0 to I is less than 8, and will be continuously increasing after increasing the value of I after each iteration. So end bit is equal to digital read bus of I, and we will check if it is 1, if it is high then consider it as 1, if it is low then consider it as 0. And then what we will be doing will be further we have declared a int variable value here which will be signed bit. So here value is equal to value, as this is a bit, it will be a single bit number, and we need to store each and every value. It will be a 8-bit value. So after defining it, we have to define these at unsigned 8-bit value. It will be a signed 8-bit value, it will be signed 8-bit value. And now after that value is equal to value, will be shifting each bit after shifting one place and adding the new bit to that value after each iteration. And then after that we'll be going into the loop, while loop, and LCD output code will be written here, and this way we'll be designing our output register. So thanks for watching. Stay creative with me, TechnoFetch.